Today we're going to talk about two projects that recently won funding through NASA's 2021 NIAC program. Both studies investigate using mycelium in the context of space exploration and space resource utilization. Before we dive into these projects, we'll set the stage with some of Carl Sagan's thoughts on synthetic biology for space applications. Then we'll look at the NIAC Phase 2 project entitled Mycotecture Off-Planet, followed by the NIAC Phase 1 project called Making Soil for Space Habitats by Seeding Asteroids with Fungi. Finally, we'll discuss the overall impact of these studies on the field of space resources. First, some thoughts from Carl Sagan on terraforming the Red Planet. In his 1980 book Cosmos, Sagan postulated that the polar ice caps of Mars could be vaporized to release trapped atmospheric gases. One way to do this would be to darken their surface so they absorb more sunlight, but coating the caps with a layer of dark dust would pose multiple problems. Sagan's preferred solution included a genetic engineering program to create organisms such as lichen that could survive the harsh conditions on Mars and reproduce enough to cover the target areas. He envisioned some kind of Johnny Appleseed figure, human or robotic, helping to spread these organisms that would transform the Martian environment for future generations. Although this idea is extremely interesting, it does not adhere to Article 9 of the Outer Space Treaty, which serves as the basis for the principle of planetary protection. On the other hand, the Mycotecture Off-Planet group from the NASA Ames Research Center has already factored planetary protection into their plan. The organisms that they intend to utilize would be genetically altered to not survive and proliferate on the Martian surface. Before we go off-planet, let's first define the word mycotecture. Mycotecture is a portmanteau of the words mycology and architecture. Since mycology is the study of fungi and architecture is the art of structural design, mycotecture simply means using fungi to design and build structures, and off-planet means somewhere other than Earth. This group investigating mycotecture originally received NIAC funding in 2018 for Phase 1 implementation. During this period, the overall viability of the concept was studied, and the technology readiness level was advanced through various developments and deliverables. The team was also nominated for the Best Manufacturing Project and the Best New Composite Part in the Student Synthetic Biology competition. This year, Phase 2 has been funded to take the project even further. Small prototypes will be developed to test key technology parameters such as the type of fungi that should be used. Lightweight porous scaffolds will be coated with nutrient hydrogel or living feedstock, enclosed in plastic bags, and seeded with the live mycelia which will grow and fill out the structures. These prototypes will then undergo additional testing to analyze mechanical properties and performance in simulated lunar and Martian environments. This will serve to advance the project towards a higher TRL. The researchers also propose future enhancements of the technology that utilize bioengineering augmentation to maximize the value of this living architecture in human space habitats. Additionally, they point out that mycotecture could be used for sustainable construction here on Earth and even help to house war and climate refugees. The next research we'll look at comes from TransAstra Corporation and plans to investigate how fungi can be used to make soil out of asteroids. Produced by the researchers themselves, this image gives an overview of the proposed soil forming process. Similar to the mycotecture prototypes from the previous project, the object where the fungi grows will be enclosed in a large bag to retain the atmosphere. In this case, rather than porous scaffolding, the fungi will grow directly into the surface of an asteroid. Acid from fungal spores will help to dissolve the rocky material, and pressure built up from expanding mycelia will fracture the asteroid's surface. Eventually, this will lend itself towards the creation of viable soil for agricultural applications. The researchers envision this soil being used in large, long-term space habitats, such as the giant rotating cylinders proposed by Gerard O'Neill. Since these habitats will need to grow most of their own food, recycle nutrients, and provide ample green space for crew mental health, the team foresees a clear need for this kind of soil creation technology. Although hydroponic systems offer a soil-free alternative, the researchers point out that such systems are not ideal in the context of larger settlements. To give further weight to their proposal, the researchers point out that fungi are excellent at breaking down complex organic molecules, including those which are toxic to other life forms. They cite some examples of useful species and mention evidence that indicates fungi played a key role in the early soil formation of Earth. In this first NIAC phase, the team will identify the best fungal species to carry their experiments forward. They will test several different approaches with simulated asteroid material and rank the alternatives in terms of productivity, estimated costs, and the ability to support a target mission in the relative near term. Finally, let's take a look at how this research might impact the wider field of space resources. All of the ideas that we've explored here are fundamentally concerned with human expansion beyond Earth. In order to realize a permanent human presence throughout the solar system, we'll need such technologies to support us as we learn how to utilize the various available resources. In addition to optimizing habitat formation and space-based agriculture, the combination of mycology and synthetic biology offers great promise for biomining, water filtration, and self-repairing structures. If we want to make the solar system as habitable as Earth, we'll need to enlist the help of all Earth's wonderful life forms. Thank you very much for your time.